Okay.
So that will give us d ds of dy ds, meaning we'll now differentiate d the second time. So if you differentiate the second time, r will come down and multiply this r. That will give us r squared e raised to power rs. That's differentiating the second time. So we'll now substitute these three into the differential equation. So
Wow.
y prime prime plus 3y prime minus 10y equals 0 becomes, now y prime prime, I'm going to substitute r squared e raised to power rx plus y prime, that's r e raised to power rs, that will give us 3r e raised to power rs minus 10y, y which is e raised to power rs equals 0. So if you look at the left-hand side closely, you will see that you can factor out e raised to power rs.
Yes.
And you now have in the brackets r squared plus 3r minus 10 equals 0.
Yeah.
Now, r squared plus 3r minus 10 equals 0, since e raised to power rs cannot be 0. So you know that if two entities equal 0, two things are likely to happen. It's either that one of them is 0 or both are 0. But in this case, e raised to power rx cannot be 0. Do you know why? E raised to
No, sir.
power, or e alone, has a value.
Yeah.
Does that make sense? You know, there's a
Yes, sir.
value for e.
Yeah.
Now, irrespective of what
Fine.
r or x is, so there's no way that can be 0. At worst, it will become 1 if r or x is 0. Do you get that now?
Yes, sir.
So at worst, e raised to power rs will be 1. It can't be 0. So we are pretty sure that is r squared plus 3r minus 10 that is 0. Hope that makes sense to you.
Yes, sir.
Okay.
Yes.
So we'll now solve that quadratic in R. So to now solve that quadratic in R, what are the factors you think we do that? Minus 10 then plus 3. So R
Plus 3.
squared,
5 and 2. That will
5,
be
5 and 2.
5 and
Okay.
minus 2.
Yeah.
Plus
So
5 and
plus
minus 2.
5R minus 2R minus 10 equals 0. So we now have R into R plus 5 minus 2 into R plus 5 equals 0. So you have r plus 5, then r minus 2 equals 0. So r equals minus 5 or 2. So you have determined r that satisfies that differential equation. So invariably, what it means is that the solution of that differential equation is y equals e raised to power minus 5x or e raised to power 2x. That's the
Okay.
solution of the differential equation.
Okay.
That's what it
Okay,
means.
so I've not copied this. I'll
Yeah,
copy it now.
copy that very quickly.
Okay, I'm there, sir.
Okay, so that settles
Number 7.
question 7. So let me just erase this for question 8. All right. So question 8 is going to be numerical. So get your calculator with you.
Okay.
I think the question says we should use Euler method to solve that differential equation. And the differential equation is dy dx equals 1 minus sy using the initial condition y of 0 equals 0. And you should use a step of 0.2. That's h equals 0.2. Am I communicating? Now, in our coursework, we did not dwell on this because according to your material, it was something that was just brief there. That's why I
Okay.
didn't dwell too much on it.
Yeah.
It's more of numerical. That's why I say you should get your calculator ready. So there are a number of things you will do. Now, this differential equation given to you, we will express it as a function of x and y. So let me just generalize it by saying f of xn, y of n equals 1 minus xn, yn. That's the differential equation given to us. Now, we now have xn plus 1 equals to xn plus h. So this will determine iteration we are going to carry out. And of course, we'll say that where n equals to 0, 1, 2, 3, and so on. So that's that's n. Am I communicating?
Okay.
Now, Euler's formula, I think we were given in that question, I'm not too sure, by Euler. Sorry.
Okay. So, sir, xn plus 1 equals xn plus h.
Yes.
Okay.
We are going to use that to iterate values for x, n. Is that clear?
Okay.
Okay.
Yeah.
So the Euler's formula will now be y of n plus 1 equals to yn plus h times f of xn yn. So you have that. Now let's get our x. When n equals 0, I don't know if I should tag it. Let me tag them so that it will be easy for me to make reference to. So this is 1, this is 2, this is 3. Now when n is 0, x n plus 1 will become s1. Are you with me?
Yes. When
Equals
n
s
x
naught plus h.
when x to n is 0, yeah.
You get that now? And
Yes.
s naught, that's your initial value. S naught is 0. Y naught is 0 from the initial boundary given to us here, initial condition here.
Yeah.
So S naught is 0, Y naught is 0. Initial condition. So let's substitute that. So that will be 0 plus H. That's 0 plus 2, 0 0.2, which is 0 0.2. So S1 is 0 0.2. Now, F of S naught, Y naught. I'm using equation 1 now. So that will be
Okay.
1 minus S naught, Y naught. Are you there?
Yes, sir.
Okay. Now substitute S naught, Y naught. That's 1 minus 0 times 0, which is 1. So f of S naught, Y naught is 1. Now using equation 3 now, Y1 will now be equals to Y naught plus H times f of S naught, Y naught. You can see all of this is when n is 0 that we are doing. You know, when n is 0.
Okay, yeah. Thank you.
Take note of that. So we have determined Y naught. What is Y naught? We just determined that now, 0 from the initial condition given to us, plus H, 0 0.2, times f of S naught, Y naught. F of S naught, Y naught is 1. So times
Yeah.
1. So that will be 0 0.2 times 1 plus 0, 0 0.2.
0.2.
So Y1 is 0 0.2. We have solved for that. So you have to write that quickly.
Okay.
This time I'm not going to clean it. So I will move to next page because I will need to come back to it.
Okay, sir. Mm,
So write that quickly. If you have questions, let me know.
okay. Okay, I'm different.
Okay, so let me clean.
Oh, it's like you say you go to the next page.
No, I've seen I can clean some of the thing. Let me just clean this. You understand that now?
Okay. So when n is 1 now.
Uh,
Okay.
okay, I think it makes sense now. So
Mhm.
when n is 1, then you know xn, which is our equation 2, xn plus 1 will become s2,
X2, yes.
and xn will become s1. So what's the value of x1 that we have obtained? So you really want to tell me now,
Oh,
I've cleaned it.
okay. The value of x1 is 0.2.
0.2. So it will now be 0.2 plus h, also 0.2. That will give us 0.4. Is that clear?
Yes.
Now, oh, I didn't clean this 0. So s f of xn comma yn now will now be f of x1 comma y1 1 1. So let's now substitute. So that will now be 1 minus x1.
Mm.
Our x1 is what? 0.2
Oh, sorry, 0.2. Yeah. Yes, no.
times y1. The y1 we obtained,
Y1 is 0.2 as well.
0.2. Okay. Now, 0.2 times 0.2 will give us what? 0.0,
0.4. Zero. Okay.
0 what?
0.004.
0.04. Okay, 1 minus that. That should be 0.96.
Yeah. 0.96.
0.96. So y2 now, using equation 3, you know, when n is 1 now, that's what we are doing. So it will now be
Yes, sir.
y2 equals y1,
Y1.
then f of x1, comma
Yeah.
y1
Um,
will now give us, our y1 is what? 0.2
0.2.
plus h, which is 0.2, times s1 y1.
0.96.
What's that?
0.96.
0.96. Have you?
Yes, sir.
Now that 0.96 times 0.2 plus 0.2 will give us what?
0.392.
0.392. That's our y2. Copy that quickly. I want you to go and carefully study this. You call it numerical method of solving differential equation. And it's not something you rush to do.
Yeah.
You know, you are dealing with decimal.
Yes, sir.
You have to be very careful. It's not something you do and be chatting with your friend. If anybody asks
Yeah.
you a question, it's true. It's not something you do and turn your head.
Yes, I can see that. Yeah.
Otherwise, you mismatch figure.
Okay, I'm there.
Okay. So let's now clean that again and do when n is 2. So now when n is 2, so our xn plus 1 will now be s3
3.
equals s2 plus h. So what is s2?
0.4.
0.4 plus 0.2. Agreed?
Yes.
And that gives 0.6.
Yeah.
So f of x n, that's f of s2,
X2,
comma
Y2.
y2, will now give us 1 minus s2 y2,
Y2.
and that's going to be 1 minus s2, which is
0.4.
0.4 times
Y2.
y2,
0.392.
0.392. Yes, multiply and subtract it from 1. That should be 0.84 something.
Yeah, 0.8432.
8432.
Yeah.
So y, using equation 3 now, y of n plus 1. So we have 10 minutes left. So
Okay.
y of n plus 1 will now become y of 3 because n is 2
Okay.
equals to y2 plus h times f of s2,
Okay.
y2.
What?
So that will give us y2. What's our y2?
0.392.
0.392 plus h, which is 0.2, times f of s2 y2, which is
0.8432.
0.8432.
Okay.
So multiply that and add to 0.392.
0.5606.
5606. Very good. So that's y3.
Sure.
So copy that quickly. Now, take note of something. Don't approximate prematurely or
Okay.
don't truncate prematurely. So always leave your answer in 4 decimal places until final answer.
Okay.
Take note of that. For
Okay.
instance, when you're
Okay.
supposed to write 0.8432, you now write 0.84.
Okay.
So it's going to affect your final answer. They're going to have cumulative error of approximation.
Yeah.
Take note of that.
Okay. Yes, sir.
Done?
Yeah.
Okay. Let's see what you can do in the next 5 minutes. So we'll now do when n is 3 now.
So, sir, is there a time we will stop? When do we,
No,
how do we know when to stop?
the platform we are using is programmed to give me 40 minutes at a time.
Oh, oh, no, sir, about the question. When do we know when to,
Very good. I like your question.
okay.
You stop when the value is repeated. For instance, now we have obtained y3 to be 0.5606.
Yes.
Now, if we now do y4 and we have the same value,
Yeah.
then we stop.
Yeah. Okay.
So you stop when y of n plus 1 is equals to y of n. Hope that is clear.
Yes, sir.
Okay. So when n is
Three.
3, so you now have S4 equals to S3.
X three
And
plus
what's our
three.
S3 the other time?
0.6.
0.6 plus 0.2. That's 0.8.
Mhm.
So f of S3, comma
Mhm.
Y3 will now be 1 minus S3, Y3. So that
Okay.
gives 1 minus, what was our S3?
0.6.
0.6 times Y3 that we just obtained now,
0.5606.
0.5606. So
Yes, sir.
multiply all of that. That should be
6636.
0.6636. Is that clear?
Yes.
So y of 4,
Y of 3.
no, y of 4.
Okay. Oh, Y of
Don't
4.
forget
Yes,
we're
sir.
doing n equals to 3. So it's going to be 3 plus 1
Yes, sir.
equals
Okay.
to y of 3 plus f of x3,
Okay.
y3. And that will be
Y
y3. What's
0.
our y3 that we obtained the other time?
0.5606.
0.5606 plus h, which is 0.2 times f of S3, Y3, that's 0.6636. Yeah, multiply and add everything. So we now have y of 4 to be approximately, what is that?
0.693334.
34.
Okay.
Yes, 33632. That's what we are supposed to have.
Yeah.
In 4 decimal,
Yeah.
6934. Oh, yeah,
That's
write
nice.
that quickly. You have 3 minutes.
Okay.
So we'll just do more. We'll just do 2 more iterations. We'll do Y5 and Y6. And let's see what happens. We should be able
Okay.
to terminate it at Y6. Then there are times that the question will specify the number of iterations to be carried out.
Okay.
So, but when number of iteration is not mentioned in the question, you stop your iteration when the succeeding value equals to preceding value. Like if you do Y5 now, I will obtain this value, then we stop.
Okay. I'm done, huh?
Okay. Uh, we have less than 2 minutes. If I should start now,
Yeah.
let me just end it. Then you will log in again.
Okay. Mhm.